Anything which you remember? Photoelectric effect, okay. What is that? Emission of electrons from the surface of metals, right? That is photoelectrons or photoelectric effect. Okay. And then when it is connected in a discharge tube, right? So what are the important things you studied? Okay, the first graph shows as intensity increases, current also increases, right? The second graph showed that as intensity increase, the current also increased, but then when you go to the negative side, the stopping potential was same, independent of intensity. Okay, that's an important finding. Okay, that is not usually you would expect, or at least that's not what people expected. The scientists did not expect that. So they thought that when intensity is increased, right, instead of one light, if I put two lights, I thought, the stopping potential will also increase, but then that did not happen. Okay, and then the third graph showed that the stopping potential was changing with frequency, right? As we increase the frequency, the stopping potential also increased. So that means it was giving some kind of a clue that the stopping potential is dependent on frequency, but it's not dependent on intensity. Okay, that's a very important finding. So, and then what was the next finding? What was the next graph? It's so the same graph shown in a different way. As the frequency increases, stopping potential also increases, right? Like this. But then there is a minimum point. The minimum frequency is called threshold frequency, below which we don't see any photoelectric current, okay, or photoelectric effect, okay. And then the lines are kind of parallel, right? For different metals, you will get different, meaning the work function is different for different metals. What is work function? Minimum energy required to pull the electron from the surface of the metal, right? So, and so based on all these things, and then one more extra thing without the graph was, no, I'm talking about, we talked about the graphs. I told you one thing without the graph, one observation. Instantaneous process, right? So as soon as you switch on the UV rays, immediately you see some effect of photoelectric current, right? So there is no time delay at all. Immediately you see that. So we don't have a graph, but that's also important observation in photoelectric effect. So we listed all these things as photoelectric, laws of photoelectric emission. And then Einstein, improved it or explained it using the quantum theory, right? So E is equal to h nu, right? So what is for Einstein's photoelectric equation? E is equal to energy of the photon is equal to work function plus kinetic energy of the electron, right? So it is getting split into two things. So what is that law based on? What is that equation based on? Law of conservation of energy, right? Whatever energy is coming in should be equal to the energy going out. So make a note, maybe I didn't tell you that in the previous thing. Most of the things in physics, right? If you thoroughly understand law of conservation of energy, you can become scientist, right? Because you see, they understood the law very well and they have, developed a lot of laws. If you remember your Bernoulli's theorem from your 11th standard, what is that based on? Again, law of conservation of energy. Remember that? Anybody remember Bernoulli's theorem? Nobody wants to try. It's very simple. Fluid, kinetic energy, potential energy and pressure energy, right? All the three will be same at different levels, right? So the total energy will be same, right? That's what Bernoulli's theorem is based on. So what I'm trying to say here is law of conservation of energy is the most important law in physics. Law of conservation of mass is the most important law in chemistry. In all the reactions, you think that mass is same, right? Before and after. Whereas in physics, it's all energy dependent. Okay. So I hope you understood the concepts very well. Okay. People think that it is a difficult topic, but it's an easy one, right? Only thing, as I told you, these experiments were done for more than 15-20 years, and then only after Einstein's photoelectric equation it was explained very well. Okay, and it kind of improved the understanding about light, meaning it can act as photons or particles, right? Photon itself is not a particle, right? Again, it's a confusing thing, right? So we think that photons is like a bundles of energy, okay? And that's why, Einstein was given Nobel Prize for, making our understanding about light better. Okay? Many people think that Einstein was given for theory of relativity, but in reality it was for photoelectric effect. Okay? Of course, whenever they give Nobel Prize, it's not just for one single thing, right? They see what are the contribution done by the scientist for that particular field, right? So in addition to mainly it was given for photoelectric effect, but then in addition to that, he has done a lot of other contributions such as theory of relativity, special theory, and general theory of relativity. Okay, there were some extra points which were given here.